So I said there's a lot of interrelationships between different functional groups, and right after saying we can make alcohols by hydrating alkenes, the first important reaction of alcohols we're going to discuss is how you can take alcohols and dehydrate them to get back to alkenes. So here's an alcohol, stew it up with concentrated sulfuric acid and heat, and you make the alkene plus water. Mechanism of this is very much worth thinking about because it brings up an extremely important conceptual issue. The alcohol itself is not going to do this except under very, very stringent, weird conditions because it has a very high activation energy, because in order to go from the alcohol to the alkene, you got to lose the OH, and OH is a terrible leaving group, doesn't want to go. So in order to make an OH go, you'd have to have a lot of energy, a lot of activation energy to make it leave. However, if we take our alcohol with acidic conditions, and acidic conditions usually means H+, although a lot of times you'll also see it H3O+. But right now there's an H+, comes up, and of course the oxygen has got lone pairs of electrons. The electrons love pluses, and so you get a protonation of the OH. In other words, the alcohol acts as a base. So we get this intermediate here in which we effectively have water bonded on to the carbon. We got a positive charge there, but that's water. Now water is a much better leaving group than hydroxide. As you can imagine, water is very happy to exist on its own. Now at this point we have to think about two possible ways in which we can go from this intermediate that has that positive charge and the water bounded onto our alkene. Mechanism number one is that another water molecule comes up and says to the other hydrogen, why don't you come with me? So therefore donates its electrons to that hydrogen. At that point that hydrogen says to the carbon, I've got a new friend, I don't need you anymore. And so the electrons that were making the carbon-hydrogen bond move to become a carbon-carbon double bond, at which point this carbon says to the water, well, you wanted to leave anyway, don't let the lab door hit you on the way out. And so we go to our products. Alkene, right, made by losing the water, that's the water, losing this H, which effectively goes off as an H+, so that's the catalyst part of the whole thing, and making a double bond in exchange. So this is a concerted process, a one-step process to go from this intermediate to our final products. Now the second possibility is that before anything else happens, the water just says, you know, if I go, then I'm leaving behind a positive charge on the carbon. So let me do that. So you make a carbocation, and there is our water leaving. Okay, so the water's gone. So we now got this carbocation, and of course carbocations can do all kinds of things. They can rearrange, they can add on particular anions. So for example, this is why you use sulfuric acid rather than, for example, hydrochloric acid, because if you had hydrochloric acid you could just get a substitution reaction going on in here. Put in the chloride there. But anyway, you've got a carbocation intermediate. And then at that point, the water can come along, grab that proton, the electrons from that carbon-hydrogen bond go to the double bond. So that's the second of the two steps, the second and the third of our concerted mechanism we just saw a minute ago. And you get to that same set of products. You've already kicked out the water, but you've got the acid, back to the original acid catalyst there, and your desired alkene. Okay, so two possible mechanisms. One's labeled E2, one's labeled E1, and we discussed the difference between these in the extension material for the alkyl halides. Okay, essentially it comes from the fact that if you pretend that this is your starting material, then you need both this starting material and water to come on in a two species involved reaction, so a second order elimination. This one down here, however, is a first order elimination because you only need this species here to get to the intermediate, and then the second species, the water, comes in to abstract the H, is a second step. So confusingly, E2, one step from the intermediate up there, E1, 2 steps from the intermediate to your final products. An alternative A-level way to dehydrate alcohols is you just pass the vapor. So in other words, you've got to vaporize your alcohol over heated aluminium oxide. Don't really talk too much about that as in organic chemistry classes. If you want to go from an alcohol to an alkene, where dehydration, you typically do it under these acidic conditions.